Hey guys, welcome back. This time around we're going to take a look at the fundamentals of the nervous system. When you're taking a look at the nervous system, you will find that it is the controlling and communicating system in our body. It is going to be responsible for relaying information via electrical signals that integrate each thought, each action, and each emotion that we have. Along with the endocrine system, it's going to be responsible for maintaining body homeostasis. Of the two regulators, though, the nervous system is rapid, specific, immediate responder to the body's crisis. The endocrine system, on the other hand, is quite slow to respond and frequently depends upon the nervous system just to turn it on. However, once the endocrine system is online, it can take over what the nervous system has initiated, allowing the nervous system to go back to rest, permitting the opportunity for the nervous system to respond quickly to the next body crisis. Now, this also is beneficial to us because the utilization of ATP. The nervous system happens to be the most energy-hungry system in our body, whereas the endocrine system is quite conservative in the use of ATP. So when we can, we will bring the endocrine system online to manage a crisis over a long term. The nervous system typically initiates the response, manages it acutely, but it can manage it from start to finish if the endocrine system is incapable of managing that non-homeostatic event. Now we'll talk more about the endocrine system in AP2, but the endocrine system is going to be the system of organs that generate or produce hormones and secrete them into the blood supply. Here in the nervous system, we're going to take a look at the neuroanatomy first, and then we're going to take a look at the neurophysiology. From the image that you can see here, you will see that there are three overlapping functions of the nervous system. The first function of the nervous system is sensory input. By using sensory receptors that are found on the surface of the skin and within the internal organs and cavities, the nervous system is capable of monitoring any and all changing environmental issues. This information, in the form of a stimulus, is gathered and constantly relayed via sensory nervous pathways. Here it's labeled as sensory input. The sensory input is also normally called the afferent nervous pathway. This information that is being received at the receptors is going to travel down this sensory input towards the integration site. Now the integration site is going to be the central nervous system. Now the central nervous system, it could be the brain and or the spinal cord. If it's a reflex action, it's going to be at the spinal cord. If it requires integration and it requires a measured response, then it's going to be a process that travels into the brain. The integration site then is going to be the site that processes and interprets the input information and determines if and when a response is needed. If a response is needed, it's going to travel down to motor output. Now this motor output also later on is going to be known as the motor nervous pathway. Now this motor nervous pathway will send a stimulus, an electrical event, to an effector or organ or organs. Now these effector organs can be muscles, they can be glands, they can be organs, to exact a change that will allow us to counterbalance whatever environmental issue we're dealing with. For this reason, the motor nervous pathway is also called the efferent nervous pathway because it is targeting the effector organs. Now, before we get too deep into the nervous pathway, though, it's fair to say that there are levels of organization within the nervous system. It's easier to see these levels of organization if you view a flowchart. I would strongly recommend that you become very familiar with this flowchart because the nervous pathways that we discuss here on this flowchart will be what we will discuss the rest of this semester. When we're taking a look at this chart, notice at the very top there's two primary sources of the nervous system, the central nervous system and the peripheral nervous system. The central nervous system is going to include the brain and the spinal cord. The central nervous system structures are going to be found in the dorsal body cavity, which means they're enclosed, encased in bone. And again, they function as an integration and command center for receiving sensory information, interpreting that information, and dictating the response down the motor pathway. The peripheral nervous system, on the other hand, is going to include all the paired cranial and spinal nerves. It's found outside the central nervous system, makes up the nerves that extend from the brain and the spinal cord. The peripheral nervous system neurons serve as communication link to the rest of the body. Their nerves carry messages to and from the effector organs and the spinal cord and brain. Peripheral nervous system itself has two functional subdivisions. One functional subdivision is called the sensory or the afferent nervous pathway. This pathway conveys impulses to or towards the central nervous system from the sensory receptors. These pathways may be somatic if they're coming from the skin and or the skeletal muscles, or visceral if they're coming from the smooth cardiac muscles or glands. The second pathway associated with the peripheral nervous system is going to be the motor or efferent nervous pathway. This pathway is going to transmit impulses away from the central nervous system and towards the effector organs. Now, whether those effector sites are going to be organs, muscles, or nor glands, and thus it's going to elicit an effect or a response. This is where it gets its name, efferent nervous pathway. The efferent nervous pathway itself is going to be further divided into other subdivisions. One of the subdivisions of the efferent pathways is going to be the somatic, also known as the voluntary nervous pathway. These are going to be the somatic axons that will conduct impulses to the skin and skeletal muscle. The second efferent pathway is going to be the autonomic or involuntary nervous pathway. These are going to be the visceral motor axons that conduct impulses that regulate smooth and cardiac muscles as well as glands. These sites are regulated by, again, two antagonistic pathways. The two antagonistic pathways of the autonomic nervous system are the sympathetic and the parasympathetic. The sympathetic mobilizes the body during emergency situations, the flight, fright, or flight sensations, also the walking up the stairs sensations, anything that would put our body in a stressed, non-normal state. And then there's the parasympathetic. Parasympathetic is going to maintain the body functions during basal metabolic periods. Frequently we call that housekeeping or conservational periods. These two sets of nervous pathways, the sympathetic and parasympathetic, are going to be antagonistic pathways. That means when one is turned on, the other one is going to be inhibited. Now, when we take a look at the efferent pathway and we talk about voluntary nervous system, slow down just a moment to realize that that nervous system requires us to have conscious thought for those impulses to occur. Conscious thought means that we can train them, but we're not born with the ability to control them. We have to train them, such as talking, walking, crawling. Whereas the involuntary nervous system, or the autonomic nervous system, that's an unconscious nervous system. That nervous system will send messages to and from, regardless of whether we consciously think about it or not. Notice they control such things as your cardiac muscles, regulate heartbeats, blood vessel diameter, so that we regulate blood pressure. We're regulating the formation of urine and other stuff using the autonomic nervous system. Next time around, we'll take a look at histology associated with the neuroanatomy of the nervous system. Y'all have a great day. See you later.